Section 4.6. So first let's review the last two sections. Here are the four conjectures that can prove two triangles are congruent. If you have three sides congruent to three sides in another triangle, the triangles are congruent. If you have side, angle, side, where the angles between the two sides, the triangles are congruent. If you have side, angle, angle, or angle, side, angle. These are the four conjectures that work to show that two triangles are congruent. So let's look at these three examples and figure out which theorem would prove these triangles are congruent, if any. And remember, if it's not any of these, then it's not enough information. So the first one, if you notice, we have an angle, a side, and an angle. So this one by angle, side, angle, the triangles are congruent. And then when we label them, we name one triangle. So for example, ABC. We could say that's congruent to, name the other one in the same order. So what's corresponding to A? It's C. So triangle C. What corresponds to B? It's B. And what corresponds to, oh, I'm sorry, this is A. Let's do AB, and this should be B prime. So this will be CB and B prime. So here's a congruent statement. Just make sure you name them in order. Let's look at the next one. The next one we have angle, angle, side, angle, angle, side. So by side, angle, angle, these two triangles are congruent. And the last one I kind of cut off right here, but notice what they share. They share a side, and these sides are the same and these are the same. So by side, 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 the triangles are congruent. Okay, so those are the four that work. Okay, if two triangles are congruent, name all the parts that are congruent. So if triangle ABC is congruent to triangle DEF by side, 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 what parts are congruent? Well, angle A and angle D are congruent. Angle B is congruent to angle E. And angle C is congruent to angle F. So we have our angles covered. We also have sides that are congruent. AB is congruent to DE. BC is congruent to EF. And the last side, FD, is congruent to CA. All right, so all of these parts are congruent if it's the same triangle. In other words, the corresponding parts of each triangle are congruent with each other. This is actually a conjecture that we use. Here's the conjecture. If two triangles are congruent or exactly the same, then the corresponding parts, the parts that are in the same location, are also congruent. There's a shortcut for this conjecture, Cpctc. We're going to use this quite a bit in our proofs, which just means corresponding parts of congruent triangles are the same, are congruent. So let's practice using Cpctc. All right, so for each of these, we're just kind of going to write a paragraph proof explaining why these are true. So M is the midpoint of WX, so it's the middle of this line. And M is the midpoint of YZ. So these two lines are the same, and these two lines are the same. It's asking you, is this line congruent to this line? Why? All right, first step, we want to show the two triangles are congruent. So which of the four theorems can we use? And if you notice, this is side, angle, side. So we can say by side, angle, side, this triangle, so triangle YMW is congruent to triangle, let's see what goes with YZ, MX. So those two triangles are congruent by side, angle, side. If they're congruent, triangles are exactly the same. So we say by Cpctc, the triangles are exactly the same. So then YW corresponds to ZX. So those must also be the same. Okay, so there's an example of a paragraph proof. Let's do the next one. ABC is isosceles and CD is the bisector of the vertex angle. So it means C is the vertex angle, it's the bisector, so it cuts this in half. These two sides are the same. Is AD congruent to BD and Y? Alright, so first step, try to prove the triangles are congruent. And by side, angle, side, these two triangles are the same. So triangle ACD is congruent to triangle BCD. And if those triangles are the same, by Cpctc, the corresponding parts are the same, so these two parts correspond. So AD must be equal to BD because they're exactly the same triangle. So there's examples of how we can use Cpctc. Alright, one last practice problem with Cpctc. TRAP is an isosceles trapezoid with TP congruent to RA and PTR. This angle congruent to ART. Write a paragraph proof explaining why TA, so this line, is equal to RP. Alright, so the first thing that we're going to do is I'm going to pull these apart because it looks kind of confusing. So I'm going to pull apart this triangle here. This is PTR. I'm just going to mark what was the same. So angle T, we had this. And we had the other triangle. Didn't draw it very well. We have ART. And we had this angle and this side. And notice they share a side right here. So here's that side. I want to show that PR is the same as AT. Alright, so first step, we're going to say, okay, these triangles are congruent, so by side angle side, triangle PTR is congruent to triangle ART. Okay, if those are congruent by Cpctc, PR is congruent to TA, which is what we were trying to prove. Alright, we could have gone further. We could have said what was given. TP equals RA was given. Angle PTR congruent to angle ART was given. And TR, we know, is equal to itself because it's the same segment. Alright, so that's how we can get side angle side. Triangles are congruent. By Cpctc, those two lines are the same. Alright, so practice the Cpctc. Here's the assignment, 1 through 11, page 233.